For all of human history, we have stared into the night sky, searching for patterns, for order in the cosmic chaos. We search for signals, for anything that might suggest we are not alone. Most of what we find is the beautiful, random noise of creation and destruction, the steady light of stars, the explosive death of supernovas. But what if we found something different? What if, buried deep in the data from one of our most powerful space telescopes, we found a signal that was anything but random? Imagine an invisible something near the heart of our galaxy, that for a brief period winks at us, unleashing a torrent of high-energy gamma rays, and then it goes dark. And then it does it again and again. Not randomly, but with the perfect clockwork precision of a cosmic metronome. A pulse that repeats every 27 days. For over a decade, this object, known as GGEJ 183921047, was a complete mystery. An impossible heartbeat in the galactic dark. Was this a natural phenomenon so strange we had no explanation for it? Was it the signature of an exotic object we never knew existed? Or was it something else? A beacon, perhaps, from a civilization far more advanced than our own, patiently pulsing, waiting for someone to notice. To understand this mystery, you first have to understand how we found it. We didn't see it with our eyes. This discovery was made in a universe that is completely invisible to us. The high-energy universe. Our sky is filled with light we can't see, X-rays, infrared, and the most energetic light of all, gamma rays. Gamma rays are produced by the most violent events in the cosmos. Exploding stars, matter swirling into black holes, and rapidly spinning stellar corpses. To map this violent sky, we use instruments like the Fermi Gamma Ray Space Telescope. For over 15 years, Fermi has been our eye on this energetic universe, scanning the cosmos and charting these cataclysmic events. A few years ago, a team of astronomers at the Max Planck Institute in Germany were sifting through more than a decade of Fermi's data. They weren't looking for a repeating signal. They were just mapping the galactic center, the most crowded, chaotic, and dangerous neighborhood in our galaxy. The center of the Milky Way is a tempestuous place. Millions of stars are packed into a space just a few light years across, all orbiting a supermassive black hole for a million times the mass of our sun. It's a place where stars are born and die in rapid succession. It's the perfect place to hide a secret. And while analyzing the data, the scientists found one. A single, distinct point source, not far from the galactic plane, that was pulsing, fading in and out of existence with a period so strange, so long, and so perfectly regular, it defied all known explanations. In astronomy, finding a periodic signal is a very big deal. It usually means you found something spinning, or something orbiting something else. But the 27-day cycle of this object was a profound puzzle. It immediately sent astronomers scrambling to identify what it could be, and one by one, all the usual suspects were ruled out. Their first thought was a pulsar. A pulsar is a type of neutron star that's superdense, a collapsed core of a massive star that has gone supernova. They spin incredibly fast and have powerful magnetic fields that shoot beams of radiation out of their poles. If the beam sweeps past Earth, we see a regular pulse like the beam from a celestial lighthouse. But here's the problem. Most pulsars spin in seconds, or even milliseconds. The slowest spinning gamma ray pulsar ever found has a period of 23.5 seconds. A rotation period of 27 days is so slow, it breaks the known physics of how pulsars are supposed to work. At that speed, the dynamo effect that generates their energy should shut down. They become dead. Pulsar spinning this slowly shouldn't be able to produce gamma rays at all, so it wasn't a pulsar. Binary system. Perhaps it was two stars orbiting each other every 27 days. The gamma rays could be produced when the two stars interact or when one eclipses the other. But the signal from this object didn't look like that. It was on for about a week of its 27-day cycle, which is too long for a simple eclipse. And the energy spectrum of the gamma rays didn't match any known gamma ray binary system. So it wasn't a pulsar. It wasn't a normal binary system. Could it be a magnetoron? Even more exotic type of neutron star with a magnetic field a quadrillion times stronger than Earth's S? Magnetars can produce powerful gamma ray outbursts, but these are typically chaotic, unpredictable events, not a stable, repeating clock. Every conventional explanation failed. The object was a ghost. When all natural explanations fail, the human mind inevitably turns to the unnatural. A stable, repeating high-energy beacon near the center of the galaxy is quite literally the dream signal for those involved in the search for extraterrestrial intelligence, or SETI. The 27-day period is long, but its stability is precisely what one might expect from an artificial source. Could this be a navigation marker for a galactic empire? K-power source for a massive alien megastructure, cycling on and off? Or just a simple, powerful "we are here" message broadcast across the ages? The idea is intoxicating. But as always in science, before you can claim aliens, you have to exhaust every other possibility. And recently, astronomers have landed on a new theory, one that doesn't involve alien intelligence, but is, in its own way, just as strange and revolutionary. The leading hypothesis is that this object is a new, previously undiscovered type of star, an ultra-long period magnetar in a binary system. Here's how this weirder, more wonderful explanation works. The object is a magnetar, a neutron star with an insane magnetic field, and it is spinning incredibly slowly, which is why it doesn't behave like a normal pulsar. The gamma rays are not being generated by its rotation. Instead, the magnetar's powerful, twisted magnetic field creates a powerful wind of particles, constantly streaming away from the star. This magnetar is not alone. It is orbiting a normal, nearby companion star. The 27-day period is on the magnetar's rotation at S, the time it takes for the two stars to complete one orbit around each other. The Gamma pulse is generated when the wind from the magnetar slams into the photons, the light being emitted by its companion star. This cosmic collision boosts the photons' energy, turning them into gamma rays. The on phase of the signal is simply the part of the 27-day orbit where the two stars are aligned just right for this collision to happen from our point of view. So, the mystery of the 27-day pulse has been solved. It's not an alien beacon. It's a new kind of celestial engine, a new species in the cosmic zoo that we never knew existed. It's a star system nicknamed the Old Faithful of Space for its reliability. This discovery is a classic example of how science works. An anomaly in the data, a ghost that defies explanation, forces us to throw out our old models and imagine something new. And this solution creates its own deeper mysteries. How do magnetars get this slow? The physics behind it are not well understood. Finding this object proves that they exist, and now we have to figure out how they are made. For over a decade, this strange glow was an impossible heartbeat in the galactic dark. It challenged everything we thought we knew about the life and death of stars. It forced us to think bigger. It leaves us with a profound and humbling final thought. How many other impossible signals are still buried in our data? How many other new kinds of stars, new celestial mechanics, or new cosmic wonders are just sitting there, patiently winking at us from the darkness, just waiting for the right eyes to notice their rhythm? The universe is not only stranger than we imagine, it is stranger than we can imagine. If you were captivated by this cosmic mystery, you must learn about the evidence for Planet 9, the massive, unseen world that may be hiding in our own solar system, tugging at it from the outside.